Good morning, students. Today we are going to discuss physics problems according to different cognitive levels of Bloom taxonomy. Problem number 1 is an insect is climbing up a 30 feet vertical wall. Starting from the bottom, it climbs up 3 feet during the day and slips down 2 feet at night. In how many days will it reach the top of the wall? The choices are 31 days, 28 days, 30 days, and 27 days. Now, how we will think about this problem? Insect is climbing up 3 feet during day and 2 feet climb down during night. So that means during one day and night, the total rise of the insect will be of 1 feet. So according to this, insect will climb up 27 feet during 27 days. Now on 28th day, insect will climb up 3 feet high. So the total height will become 30 feet. So here in the problem, we have to give that in how many days insect will climb up to 30 feet. So the total days will be 28 days. So our answer will be 28 days. But now you see, some students can also interpret it like this, that if during one day and night, insect is climbing up 1 feet, so according to that, during 30 days, it will be 30 feet. So that means in this problem, we are thinking critically. We are taking how the insect is climbing up and down. So not taking directly. So now it means that this problem comes under cognitive level, that is critical thinking. Now we will talk about next problem. Next problem is carbon and silicon both have same lattice structure having 4 bonding electrons in each. However, carbon is an insulator and silicon is a semiconductor. Discuss. Here we have to use our knowledge. Knowledge, what is knowledge? That means our basic understanding of band gap. Because you know, it is according to the band gap that we can distinguish between semiconductor and insulator. In case of carbon, energy band gap is quite high, and at room temperature, electron cannot jump from conduction band to the valency band to conduction band. So it means that it will comes under insulator. But in case of silicon, energy gap is of the order of 0.7 electron volt. So at room temperature, very few electrons can possess so much energy that they can jump from valency band to conduction band. So the presence of electrons in the conduction band and holes in the valency band will contribute to the consideration of silicon as semiconductor, because current can flow through it to some extent on application of electric field. So that means this problem comes under knowledge and understanding cognitive level. Now, problem number 3 is how photoelectric current varies with frequency of incident light when intensity of light is kept constant. Now in this case, first of all we have to see that frequency of incident photon must be greater than threshold frequency or minimum equal to threshold frequency so that emission of photoelectrons is possible. Now, if the frequency of incident photon is equal to or more than threshold frequency, then emission of photoelectron take place, because these photons possess sufficient energy to knock out electron from the surface of the matter or from the inner orbits of the matter. Now, when frequency of incident light is increased, keeping its intensity to be constant, it means that energy of incident photon will increase. Now the energy required to knock out electron from the surface of matter, which is known as work function, that is same. So the rest of the energy, which is appearing in the form of kinetic energy of emitted electron, that will increase. Actually, in this case, we are using photoelectric equation, that is energy of incident photon is equal to work function plus kinetic energy of emitted photoelectrons. So it means that when frequency of incident photon is increased, then kinetic energy associated with emitted photoelectrons will increase. It means that more stopping potential is required to stop the fastest moving electron. It means that with increase of frequency of incident photon, there will be increase in the value of stopping potential, but in this case, saturation current will remain the same. So now we are analyzing it from photoelectric equation. So that means this problem comes under cognitive level, that is analysis. Now, next problem. Potential difference V is applied to a copper wire of length L and diameter D. What is the effect on electron drift velocity by doubling potential? So in this case, it is given that when potential difference V is applied to the copper wire, then drift velocity is Vd. So now we have to see that what will be the change in the drift velocity when its potential is double, keeping its length and diameter to be constant. Now here we have to use the formula for drift velocity. That is, drift velocity is given by Vd is equal to ev tau divided by m into L. Here E is charge on electron, m is the mass of electron, L is length of conductor, tau is relaxation time, and V is potential difference. Now in this case, all other factors are kept constant, only potential difference applied, V is doubled, so it means that drift velocity is also doubled. So now here we are applying formula for the drift velocity, and directly from the formula we are getting the result. So this problem comes under cognitive level, that is application. So students, viewers, I think that you must like my video. So please subscribe my channel. Thank you.